Sonia, am I audible?
Yes, ma'am.
Okay, in the previous class, we have seen the example on the uh, code generation for expression, and I have evaluated how the code will be, and I mean how the code will be generated based on the parse tree, based on the parse tree. So today also, uh, the code generation. Actually, the code generation represents the two forms, that is the postfix notations and the address, three address code. In again in three address code, and we have we have again two types, that is quadruple and not only quadruple, we also have the triples triples code generation. So, in yesterday's class, I have told you about the code generation for something like three address. Let me open that example, what we have seen. Today, we shall see by looking into the postfix notation also. And we shall also see the yesterday, covering the yesterday's example. And with that, we shall see the next one. So yesterday's class was the code generation. As I said, there are many more basic building blocks of any language that has to be compiled by the compiler. So those basic building blocks, something like assignments, something like loop, while loop, and something like in looping we have for loop, while loop, and also we have the conditionals. Again in conditionals many more we have, just I have written here only the if else, and also the something like label statements, and based on the switch case. So these all are nothing but the basic building blocks. These all are nothing but the basic building blocks, and basic building blocks of a language. Particularly here we know the language, something like C or C++, the Java. So based on that, thinking that the high level language in mind, so we have here the assignment operators, sorry, the assignment expression, for loop expression, while loop, and conditional, and also the switch cases statements. So such basic building blocks, how the code is generated, because after all, and nothing goes in vain, or nothing goes in air, simply in air. Everything has to be scanned. That scanning is nothing but everything must be tokenized. So how a compiler doesn't leave even the dot, and that dot also how it has to be, how it has to be syntactically should be represented, and why that dot, that is nothing but representing the meaning, why that dot and why that semicolon, and why any, whatever you take, anything in the sense, any block, any basic building block of any language of a particular, because of any language also I should not say, I must say of a C language, of a C language, or of a high level language, because we are studying here the compilers. What we are learning here, the compilers, and the compile, all these codes are represented by the registers and address descriptor. This register and the address descriptors will keep track of what is the currently if I go with the register, what is currently the register is being used during the code generation, and it shows the status of that registers also. And I have also shown you how is the format of that register, and also the format of that not only the register, even also the format of the operand, what the operand we are going to use. So that operand descriptor also we have seen in terms of the figure which I have shown from the Thamdre textbook. So the in that figure, really, we have come to know how the status of the registers and the operand descriptors will be there. So uh, how a code will be generated, particularly looking at today's class, a code, and also I have told you how is the size also. So here the size indicates here something like the cost of that, what is the pain, what is the pain it is taking to represent any, like if it is a register to register means the size or the cost can be only one. The cost of, if it is if there is any movement from register to register, so the cost can be only one. If there is any movement from register to some memory variable, so the cost, it will increase or something, it can be like one, sorry, something it can be like two. And if there is something more, the more work is taken towards movement of or some other instructions or something like add. Let me show you here the example. So something like this, if the add, if the add operation is taking something like this, the add between the register to register, add between register to register. So the cost here it is one, and here the cost, the add between the register with another identifier, that is the variable, memory variable. This is the same add instruction. For the same add instruction, the cost is 2. For the same add instruction, the cost is 2. And here if you come up with the other example, here there is a movement between a register and there is a movement between a register and a memory variable C for the same variable and for the same register, for the same variable and for the same register. So here the cost is something like 3, 1, only because of instead of add it is taken here the move instruction. So here the code all depends, the code generation all depends on the size also, sorry, on the instruction what we are taking. So based on that it also decides the size of the particular instruction or the particular statement. So as a register descriptor is used to keep track of what is currently in each register, and the register descriptor also shows something very initially all the registers, it will be very empty, it will be empty, and the address descriptor stores the locations where the current value of the name can be found at the runtime. So addressability, whether the addressability is a register or whether the addressability is the R. This all format I have shown you in the previous class. If you would like to see once again, if I'm not wrong, saying only reading, showing only the document, so I can also show you the pic what we have studied in the yesterday's class. So that it is in my mail, that figure. So that figure also I would like to show. Yes, am I audible? Onkar, okay, no need of that figure, I think. Or let me check in my downloads. Onkar, am I audible?
जी मैडम, सुन पा रहे हैं हम आपको।
Okay, okay. Okay, this was the yesterday's figure for the last week class, what I was trying to show you. So here the size, here the type is int and the size is 1. Why the type is int? Because it is declared, a is declared the variable as the integer, therefore it is int. And for the second operand also it is also integer type, and the size is 1. Why the size is 1? Why? Because here there is there is only a calculating or evaluating only for particular variable, for particular variable. And for that particular variable, if suppose if I was moving from if I was moving from this I mean that memory variable to some register, so I would get here the size something like here the 1. But in this particular example, it is all, I mean as per this book, it is given all as 1 only. In case of whether it is a move instruction, or whether it is any instruction something like mult, or any other instruction something like add. So here the size of all of them is, because I have shown you the example also, I mean throughout the example, in how it was covering in all the build descriptors 6 build descriptors. So in that example we have seen the size was 1 only, the size was 1. So today let me tell you about something very in again another example. uh, Another, before going to the another example, let me clear you here. There are the code generation is represented by, or it is followed by the three different methods. The three different methods, that is nothing but postfix notation, and also the three address code, and another one is syntax tree, that is the parse tree, which I was telling you yesterday class. I have shown you this one, this example using, and this particular method, it is nothing but abstract syntax tree, and this abstract syntax tree is nothing but a parse tree. And based on this parse tree, as the parser means, and as the scanner scans in a while, as the scanner scans either the operator or the operand, so it will start generating or start loading that operand into the register, and it generates the code respectively, it generates the code. So this is how the example which we have seen in the yesterday's class. So based on this example only, one more example let me tell you. This was only a very simple example where we have seen some two term multiplications, and how it is done, and how a scanner or a parser should think that I must do first for I must do first for the multiplier, or if, how I can solve it, or how I can evaluate this particular equation. So what this compiler will have to do, the compiler should have to follow here the operator precedence. The operator precedence, you all know it, that whatever is in the first bracket, so that it has to solve first preference is given to that. If there is no bracket for a particular for particular expression, other than that, if there is any something like multiplication or the division, so the second preference is given, means the first most preference are given to those multiplication or divisions. And other than that, if there are no multiplications or divisions also, operators in the expression, so it will follow the as usual, whatever is left out with the expression, either it is a plus or minus. So but one method it will follow here, it will pass from left to right during the scan time, as it identifies each token and puts them in particular classes. Like a is found to be a variable, and the star is found to be an operator token, and the b again it is a variable. And how does it does, and it follows here particular rule, that is nothing but the syntax rule or the parse tree. What it is? Syntax rule. It is also called as syntax rule or the parse tree. So whether this, whatever the given expression is correct or not, this is decided by the syntax. And after this, what kind of meaning is generated? Once when the syntax is correct, so the automatically there is a semantic generation. Automatically there is a semantic generation. So this was a part of the, let me tell here again, the code generation for the expressions is represented by the syntax tree, is represented by syntax tree, and also it is represented by the postfix notation, postfix notation, and also it is represented or it is followed by the three address. How is that three address code generation or the three address representation? So these are the three methods which it has to do. So the very beginning, which I have shown you about the syntax tree, this was the part of the syntax tree, and today we shall learn about in that syntax tree. I was been telling you about the assignment expression, and not only the assignment expression, the looping. Today we shall see some examples on looping and while loop, and we shall also see some other basic building blocks based on this. And so postfix notation, you all know. And so here itself I'll take the example. If suppose if I have for postfix notations, you know it very well. Anybody knows postfix notations? I hope you all know it. What is postfix and infix? So if an infix expression is given, if an infix expression is given, here also it follows the operator precedence. The compiler has to follow the operator precedence, and based on that the code is generated. If suppose if I have the example something like a minus b, then this term is multiplied by c plus d, c plus d, and particularly this is also an another term, and it is also I mean this is this multiplied term is added to this multiplied term is added to another term saying as a minus b, saying as a minus b. So this is an in postfix notation which is given. So how the compiler has to recognize. Here again the compiler follows the same method, that is it has to check first the syntax. First the syntax analysis is done, and after the syntax analysis, which is not syntax analysis is also called as the is also called as the parse tree. So parse tree, after lexical analysis and after the semantic lexical analysis, and after the syntax analysis, a semantic meaning is generated. After the lexical analysis, a syntax analysis is done. So how the syntax analysis is done here? So here again the I must say here as parse tree representation. So here it first checks for the lexical analysis and whether this lexical analysis is scanned or not. While scanning, whether they are appropriately according to the syntactically or not. So now it has to evaluate based on the postfix, based on the postfix notation. So it has to evaluate based on the given infix notation to postfix notation. So here you know very well that again operator precedence is followed here. So first of all it tried to solve, first preference is given, whatever the expression is there, that expression if it is in bracket, so that is the first term which it has to evaluate uh, the compiler, and for this it follows particular algorithm, that is nothing but postfix algorithm. So in that postfix algorithm, it make use of the stack. It makes use of the stacks. Whatever the operators are found, those operators are pushed on to the stack. If here the operator is left bracket, so it is pushed onto the stack, and a is also pushed onto the stack, and minus is also pushed onto the stack, and plus is also pushed onto the stack. Once the right bracket is found, all the elements from the stack will get popped. All the elements, all in the sense one by one, they will get popped see the till it see the left bracket. So whatever the elements are pushed onto the stack, they will be popped. They will be popped. They will pop. And now say for example a minus, even the bracket is also pushed onto the stack, minus is also pushed onto the stack, b is also pushed onto the stack. Once it c in the sense one, the top of the stack is having the right bracket, it popping start popping the operands. So it has to pop the, now after that it will check and it will build an array. It will build an array, whatever the popped elements are operand, the array will store, or array will have the array will construct these popped elements into an array, saying as the string. They it will have something like array some array. Let us take here array as input array. It will have something like a, and here what it has to do, as per the method operator precedence, it has to follow. So whatever minus is there, whatever minus is there, so that minus will be here. Here in the sense it will follow a b, and here it is minus. Why here it is minus? Here it is minus because now the array, whatever the content were there in the input array, so it will after popping it follows the particular algorithm, so that it has to push, or it has to place after an operands. Operator must be placed after a operand. So that method it will follow. Based on that, a b minus. Now still the star will be as it is. Why? Because the top of the stack, or the postfix for this string, it will be pointing to the next token. That next token, it will be as it is. Why it will be as it is in the stack? Why? Because still the time has not come for this to be popped. So only these two were popped, because after seeing the right bracket. Now here star is there, it will keep as it is, and once again the left bracket is pushed onto the stack, and even the c plus d, and once it sees the right bracket, the content from the stack are popped. Now here also the same method it will follow. Operands are kept, and even the plus is kept after the operand. Plus in the sense the operator. Now here again, once again the plus is found. The plus is found. It is same as in the input. It is same as it is in the stack, and again the left bracket is found. So here a will be popped, and b is popped, and again even the minus is also popped. Now once again it follows the same method, or the same method of postfix, operands and operators. So this is the evaluated terms. These are the evaluated terms. Still it is an infix term. So here for this infix term, so what it will do, again it will follow the same method of postfix method. So ab minus will be as it is, because as for this there are no operands. So for star, sorry, for cd is an already evaluated term, cd plus. So for this still there is a multiplier operator which it has to be multiplied. So it will do that job in the, I mean, do that as the postfix method, that is CD plus and star. CD plus and star. Why the star which I have made choice? Because the star here again, what was not evaluated, star was not evaluated, plus was not evaluated. So among these both, why the star was given preference? The star was given preference. Why? Because it has to solve at the second preference. As per this statement, the star is, now again this becomes the infix expression, and the star is something like the operator precedence. So star is a operator precedence, and this becomes the operand. So operand and operator is placed at the output string. Now again, still at the last final, plus is not evaluated. So these content in the sense the AB operand minus and whatever the value evaluated of the AB result and the CD result with its addition, whatever this, it is being multiplied. Now it is being multiplied with CD. Now that is being added with AB. But AB is already evaluated, which is of the resultant. If suppose if I have a direct terminal here, 5 minus 3, I would get here 2. I would get here 2. Of course, it is evaluated. I would get here 2 with minus. 2 with minus. So here now it is added. So AB minus whatever is the evaluated one, which is added. This is how the postfix example. Postfix notation. And in three address code, that is nothing but the, I mean, intermediate variable generation. In that intermediate variable generation, in three address code, we have two methods. One is quad, triples, and the other one is, and the other one is quad triple, and the other one is the triples. Quadruple. Yes, is my screen is audible? Sorry, not audible. Is my screen is visible? Can you all see this sharing of the screen? Yes. Can you all see? Yes. Vivita. Vivita. Shruti. Ahalya. Saloni. Sanyogita. Ritwij. Shivani. Always Onkar is responding anyhow. Siddhi.
Yes, ma'am.
Uh-huh. Is my screen is visible?
Yes.
Okay. Now next another one we shall see, that is quadruple. One is the quadruple and the other one is the triples. In quadruple and triples, how the three address code is generated. How the three address code is generated. Here again, let me take the example. This was yesterday's class which I have shown in syntax tree. First method is over, and today the second method is also over. This post, there are several examples. Okay, there are several examples on the postfix method, so you all might have learned in your lower semesters class, so I need not to tell about it much more on the postfix notation. So postfix notation is also a part of the code is also a part of the one kind of an expression. So how that expression will be solved and how a code will be generated for this. But here meanwhile it make use of the stacks. Here it meanwhile it make use of the stack. And the third method is address code. Sorry, three address code. In this we have the two method, that is quadruple and also the triple method. In quadruple, the quad in the sense we have here something like operator and argument and argument, means operator, argument 1 and argument 2, and here something like result. So here for a expression, the result for a expression to evaluate, we are dividing that into four attributes, that is operator, argument 1, argument 2, and also temporary result, and also to hold the temporary result. So here the three, that's what it is called as the quadruple. And in triples only the same method will be followed, but here the expression will be evaluated only making use of the operator and the argument 1 and argument 2, but here it will not make use of the intermediate result content. So that is what here we have the two methods. So here let me take one example, which again I need here chalk and the board. That's what I am typing here. So here, for example, uh, something like assignment example. A is assigned by B plus C, and this B plus C, and also it is having some multiplication and division. It is having some multiplication and sorry, not only multiplication, not the division. Division part I will show you in the another example. Okay, where which I have to take in another example, I will be just telling. I'll just cover the division example again in the syntax stream. For those students it may help for the for who were absent for the yesterday's class, so they can also make use of that. So here one more example I'll be taking at the end. So here, so in three address code, I have an example. What is this example? This example is nothing but there is an assignment. Basic building block here is an assignment operator, and the expression which is here, something CD is something CD. The resultant of CD is again added with CD is nothing but two operands where both of them are multiplied, and it is added with B, and it is added with B. See how the compiler will make choice of choosing the instruction on this particular on this particular statement given, or this particular expression given. How the compiler will make choose of evaluating. The compiler will make choose of evaluating by making use of again the operator precedence here. The compiler will make choose again here the operator precedence. So here the operator precedence, the first preference which is given for the multiplier, first preference which is given for multiplier. So here how does it solve? It tried to solve same thing like taking an intermediate variable, or it can directly assign something by some memory variable allocations. So here I'll take something like R1. R1 will get assigned because after all it's an example which is related with the X. Now here what is the name of the expression? The name of the expression is here the assignment. Likewise, still I am showing only the assignment only. In yesterday's class also I have shown you the not the assignment. I have shown you the plus example. I have shown you the plus example. So this plus is nothing but the it is called as an assignment. How it is called as an assignment? This would be further assigned to. How it can be further assigned to? One more root will come here. That root is nothing but equal to, and one more that equal to will yield a left subtree, because every assignment, every expression will have left operand and the right operand. So this example would be treated as the right operand. Whole evaluated will be treated as the right operand. So this plus will take another a route, that node will be followed to the route saying as assignment, and that assignment will split the left operand and the right operand. So this whole expression will act as the right operand. This whole expression will act as right operand, and from the equal to the left operand will be something a variable. If I suppose I assign something like this, x is equal to, that example we shall see later. We shall see later in the, because as I was saying that I will tell you another example. So here an intermediate variable is taken. So that intermediate variables, so this is also, it is called as intermediate code. It is also called as intermediate code. How the intermediate code? Here the temporary variable will be acting as R1. So here it will evaluate first preference, that is C and D. C and D, both the operands will be multiplied. And next, what it will do? Next, it just take the resultant of this expression that will be added with B. Resultant of this expression that will be added with B. So here R1 is, and let me take capital R1 only, is added with B. Now hold together also we can do in this way. As I was saying, A will be equal to, or A will be equalized or assigned to what? R2. Who is R2? R2 is having the whole result. R2 is having the whole result. So this part is called as the, when solving in this way, it is called as the quadruple. How still quadruple it can be called? Say for example, I'll just take here operator, or the argument 1. I'll just construct here one table. Using the table, let me show. I need here 4 columns. So I'll take here 4 columns, and the number of expressions which I have solved here, that is a multiplier I have solved, and I have solved for plus 2 times, and also it is equalized. So total number of operators which I have as total number of operators which I have as 4. So I need here something like 4 operand. Sorry, operator. So here operator, then argument 1, argument 2, let me write complete word, argument 2, complete something which is understandable, and here the result. Every time how many results we have here? We have here 4 results, sorry 3 results, R1, R2 and A. R1, R2 and this A is small a, where it is equalized. This A. Okay, this A is holding the result, or is holding the evaluated result. Now A is having the value. The very first one which was solved for the operator called, which operator precedence was solved? Can anybody tell? That is star. Which operator precedence was solved? That is star. And star, what the argument it was having? Something C, also D was multiplied. C and D were multiplied. And what is the result? The result was R1. What is the result? The result was R1. It was stored in R1. What is the second operator? Well, what the compiler was looking? The second operator, the compiler was looking at plus. That plus, and it was adding the result of, argument 1 with R1, this resultant R1. Who was the argument 1? B. B was the argument 1, and it was added with whom? It is added with the previous result. That previous result was R1. The previous result was R1, and it was stored in R2, and it was stored in R2. And next again there was an addition. What was there? There was an addition. What addition? What addition it was doing? B with added with R1. Sorry, I have shown that B added with R1, and it was having the next result. It was having the both the results were added, R1 and R2. What is R1? What is R1 here? R1 is C multiplied with D. R1 is C multiplied with D. And what is the argument 2? What is the argument 2? The argument 2 is something like R2. The argument 2 is something, sorry, the argument 1 here I will take the argument 2, and here I will take as argument 1. Argument 1. Who was R2? R2 was this, the resultant of R1 with B. The resultant of R1 with B. This was the addition. And again later this indicates a add statement. Add the resultant to the result of R1. Add the resultant to the result of R1. What is R2? R2 is nothing but whole resultant. And what is R1? R1 is nothing but having C multiplied with D. C multiplied with D. And this is in R3. This is in R3. Now, what was equalized? Equalized was R3. Again, the compiler will check what is unnecessary one. There are no arguments and the result is stored in A. The compiler will check what is the unnecessary result, unnecessary code. This part is called as unnecessary code, and it is also called as dead code where it is not required. So I will also try to remove this. So here we can make R2. The resultant is in, where the result is now, it is in A. Where the result is now, it is in A. So this is how the quadruple example based on the operator precedence. And how would be the so this example is called as quadruple. I'll write here QUADBRUPLE, quadruple example. Now there is also another example, triples code generation. Triple code generation. So I'll just copy the same thing and I'll just show in the form of the triples. For triples, it requires only the three attributes, that is operator, operands. And what are those operands? Are argument 1 and argument 2. Argument 1 and argument 2. So here the argument, what is the first preferred operand? That is the multiplier. C is multiplied with D. And next is addition. That B should be here capital B, it's coming. I must show here as small b. Small b. Okay. That B is multiplied with the previous content of R. That means the previous step. Who was the previous step? The previous step was here. This let me represent saying as here 0. Let me take here another one, the column to the left, and I will represent here as this part as 0th step or 0th address, whatever the value is located at 0th addressability. So I will call that simply in making unnecessary code extra. So this is how the optimized one. Triple is the optimized type. Triple method of code generation is optimized. So it is using the same address here. It is using the same address. It is this variable memory location. It is going and adding with the location of 0th address location where the multiplied result of C and D is stored. So it is going and adding with that, and still it is in B, and still it is in B, and it may take the another location. That is, it may take with the location as 1. It may take with the addressability location as 1. Now what at 1 will be there? At 1. Now here at 0th multiplied result at 1, a whole expression is there. Whole expression is there. And when while assigning R3, at which location it will assign to which location? It may assign to the second location. So here it will take the second location. In this second location, the whole computed value is there. Who is that whole computed value? The whole computed value is nothing but stored at second. So here I need to remove the whole computed value is stored at where? Second. The whole computed value is located from first, is assigned to second location. Is assigned to second location. So this is how in triple code generation it just removes the intermediate variables which were used as the temporary variables during the code formation. So these temporary variables are removed. These temporary variables are removed. Yes, are you understanding? Onkar? Anybody? Somebody? Tajmeen? Preeti? Chavan? Anybody? Naveen? Okay. Onkar has responded. Shruti, Rutuja, Ahilya, Chitali, Vivita, Rasika. Are you there? All of you are just went off. Keeping your mobile on and just went off, I feel. Huh? Gauri, Pranali, Anisha, Monali, Dipti Patil, Sonali. Where is Sonia? Pooja, Bhakti, then
Yes, ma'am.
Tajmin, Radhika. Who told yes? Sonia, Pooja said yes. Listening, all of you?
Yes, ma'am.
How all of you? Because you are at your home, na? How I can ask all of you? Hmm? Okay. I'll just cover with the next example now. I'll go with the other one. Just look into you should feel here. Is the fonts are visible? Onkar, do the fonts? Can you see, you people?
जी ठीक ठाक है.
Uh-huh. Now I'll go with the another example. In yesterday's class, I have shown one example, that is syntax tree. Just all the three methods are covered here. One is the syntax tree, which is the parse tree, which is also used for code generation. And postfix notation, here also it uses the code generation, and the 3 address also uses the code generation, but in their own method. All are there at their own method. So how here what the code will be generated, again here it is a small c. What the code will be generated here, the code will be generated saying as assigning some temporary variable. So here first it will tell here as mul c with d, mul c with d, and the result, whatever the result is there, time being it will be in c. And next statement we will take here as move this c to r1 register. Or what I must say here, I must say here addressability as move m, because it's a memory variable, move m. So move m areg at areg, move m at areg c. What I must say, move m at areg c. For this particular code, I will write here what it will do. The code of actions or the parse actions, the parse actions for this above statement, how it will write means, first it will tell as mul who mul, the both the variables cannot be multiplied, sorry, both the memory variables cannot be multiplied, so it has to take help of the register. So move r, I must go with capital, so one should follow the same method. Move r means register. I'm just moving the in areg the content or somebody, some c. I'm moving with areg. Now what I am doing, I'm just multiplying this areg, whatever the content of areg is having, it is holding the value of c, first argument c or the identifier, with d, with d for this code. Look into this example. For this code, how the code is generated. So two codes still, is that it is completed? Yes, it is completed, but still it has to move to the memory location. But still it has to move to the memory location. So at what location we shall move? We shall move at R1, something like R1 located. So the value which is computed, because the compiler will not, the compiler will not get the stored value directly from the register. It has to, because it will recognize only when it is in the memory. It will recognize only when it is in the memory. Hello madam, hello madam, hello. हाँ, I'm in class madam. Hmm. Okay madam. Then here we need to move the memory, with the help of the memory, the content of this register to some memory location. What is the some memory location? I have taken here R1, temporary variable. It will act as temporary variable. So here I need to move areg, the register, the value which is evaluated here, multiplied value is here. So I need to move at d, sorry, I need to move at r1. Not this r1 is nothing but an temporary variable. So this is how the intermediate code, this much intermediate code is generated for simple multiplication of this, for simple multiplication of this. And next it will follow the same code generation for this also, and next it will follow the same code generation for assigning this also. During this period a parse tree is generated here. See how much the compiler is doing. So here it, again the same loop will be called for this also. So this is how it will evaluate. I have just shown how the code is generated only for this part. And here how the parse tree will be generated. Here let me show that also. How the parse tree will be generated. For this part, like yesterday, how I have shown, how the parse tree will be generated, as it has to calculate. Here what is the expression at the root will be the star. The expression at the root will be star. Then I will take the help of some line drawing. That is, I will take the simple line. So the left of this operator, or the left of this expression, who is the expression, equal to is the expression. The left of this expression is C. The left of this expression is C and small c. And the right of this expression, I'll just copy the same thing and I'll paste here. And the right of this expression is D. C is multiplied with D. D. So like this, a parse tree is generated. Like this, a parse tree is generated. During this parse tree generation only, it will load. How it will load? Before loading this C, sorry, how it will load? It will load in this manner, in this code. So this is how it will generate. Next, one other example in the syntax tree or the parse tree generator. In the syntax or the parse tree generation, just we will see another example. So this is how, as we have finished the syntax tree, postfix notation, and the three address code. In three address code, two methods we have seen, that is quadruple and triple. In quadruple, totally attributes will be of 4 attributes, because here one temporary variable is taken. So that temporary variable is called as the attribute, saying as the result, intermediate result. So to hold the intermediate result, so totally we have here, because of the 4 attributes it is called as quadruple, because of 3 attributes it is called as the it is called as triple. And in triple method, it make use of the it makes use of the addressability. Because of addressability only, at that location's value only it is taken, and it is been assigned to the arguments, or it is been assigned to the calculation part, that arguments, whatever. So like this is the second method. So one more example, which I have noted from again the textbook. One more example in the parse tree. If suppose there is a multiple, if suppose there is a division, how the division will be done? If suppose there is a division, how the division will be done? So suppose for syntax tree only, let me write every time parse tree, so most of the students should not get confusion. Suppose I have an example. I have an example, something x is equal to some expression. What is that expression means? I have a plus b, which is multiplied. I have a plus b which is multiplied by c. Then this is divided by this value, sorry, this expression is divided by the another expression. This expression is getting divided by another expression. That another expression is something like this. That is a minus b, which is multiplied by c. Now how the parse tree will be generated here, or the syntax tree will be generated? First of all, the compiler will look into such a token where the preference where in this expression it will look into such a way where it follow from left to right, it follows from left to right. As it see left x, as it sees first left x, it will treat it as an operand, and as it go on it will see again second token as equal to. Now it start for second token, when it sees as the equal to, as it is a assignment expression, it starts doing the start treating that as the left and right expression or left and right operand. So once it sees the assignment, it should treat it as operand. So it is seeing here the expression here is the assignment. The expression here is the, let me take here very middle because it is going little bit. So the once it has seen the expression, that expression is assignment, it start treating. Now it should find out as the right operand, at the right operand. What is the right operand? And it should also see what is the left operand. As it is seeing the right operand, or as it is seeing the left operand, it is simply an x. It is simply a x. As it is seeing the right operand, first it has to check out for the highest priority among the operators plus, but still so far it will not come, it will not be known that, because it is seeing the operand a, it is seeing the operand at the first instance only, it will not come to know whether whether plus is a highest operand. It will try to go ahead and it will just check out that plus, that multiplier is the highest operand, that multiply, because till then it will be pushed onto the stack only, till then it will be pushed onto the stack. So it will just see there is some highest operand preference is given from the table. It will come to know the multiplier is given the highest preference. As it goes, still there is a division sign, so it will treat this as the next preference. So before going to the next preference, it will also give the most preference to the bracket one. So that is what, as the equal to sign is seen, the bracket is seen here. So once it sees the left bracket, it till it sees the right bracket, it will evaluate the expression inside the bracket, and it, of course it will follow, it will take from, it will push them into the stack and it will pop them. Of course it does, but it will follow the method of the, here how it has to do the postfix, how it has to do the operator precedence. So that is what the bracket is treated here. So here it will think that this is the right operand, and it has to do first at the, for the multiplier. So for the multiplier, when it has to do at the first instance, so it has to, but before that again there is a plus, so it start dividing them. So how does it start dividing them? By using the parse tree. So it has to see here the x. After seeing x, it will treat what, because equal to is an expression, equal to is an expression, and what expression? The type is assignment. What expression? The type is assignment. To this operator, because always at the root, always at the root node, always at the root node, the left Once the root node is finalized, it will just find out what is its left operand, what is its right operand. The left operand, it has detected that x is there, and what is its right operand, it should detect. So the right operand it will detect now in this way. Now to this right operand, again it has to check out for what? Again it has to check out there is something, what is the priority based. What is the priority based? The priority based for this, again there is a multiplier. There is a multiplier. The moment, because here bracket was there, bracket was there, and till it find out the right bracket, that's what the plus was not preferred at the first instance, still because it has not seen the right closing bracket. So by that time it has seen the till by the time till the closing bracket it has seen the multiplier. So it start doing, once it sees the multiplier, it uh, start doing the, or it start evaluating. So in this expression still x is at the second level. How I will do is, because this whole expression is divided by some other expression, getting divided by some other expression. So here, who is that some other expression at the preference level is nothing but the division operator, that is this division operator. But why I'm going to this? Because if I have gone at least with the multiplier, later I would have attached that. So I will just show you first the multiplier, how it will perform as the time is getting over. And just, so it should start doing for B is multiplied with C, and this resultant B and C resultant, whatever it is multiplied, this is added with A. This is added with A. How it is added? The resultant of this, the multiplied resultant of this, it is added with A. How it will get added with A in this sense? So here is the plus. Hmm. Yeah, here is the plus, and this is been added with who? This is been added with what? with A, this A. So here it should be A. I'm not getting here. Why? Because I have gone to the extreme left. Here it should be A. Right, it's coming. Here it is A. I'll take this. This is A, and this is how it has been added with that. And whole this result is being multiplied with whom? Is being multiplied by, sorry, whole this is divided by, whole this result is divided by what? This another expression. So whole this divided, it is getting, I must take like this. So this is getting divided by this another expression. In this another expression, I have here again the preference, operator preference. Who is that operator preference? That is multiplier. Here again I'll copy this all, but it won't come, I feel. So I must go here to this level. So this is multiplied. So who are all again multiplied? These are multiplied by B star, sorry, B with C, B with C. And this again is subtracted by what? This, because for this subtraction, again subtraction acts as a root node. And what is the left operand? A. What is the right operand? This is the right operand. So this should come here. So this is the right operand and left operand. The left operand of this and the right operand of this. So in this level. So in this level, again it is being added with this. So this is added. Now here what is being multiplied? Sorry, what is being added? It is being added by A. I must take here A. At this level. So A. A is not added, sorry, here it is subtracted. So the left of A is this and the right of A is this. What is the right of A? The resultant of multiplication. The resultant, I should drag this, I can drag also. the minus, this minus sign, can you see? Yeah, the minus is subtracted by the result of this multiplied, the result of this multiplied, and the left of this is this expression and the right of this is this expression, which is divided by what? So which is divided by this expression. Yes, at home you can also construct on your own. This is how it is completed. See here, the first preference is for a multiplier. B is multiplied with B is multiplied with C, and the result is, this result is added with B. This result here, small a, sorry, here it should be a, small a. This result is added with A. This result is added with A. Now for this part, the B is multiplied and it is subtracted by A. Sorry, it is from A, what is subtracted? The resultant of multiplication. So this is again further, this is again further is being divided. The resultant of this is, because now the division sign is acting as the, again the root node, and the left of this division is this expression and the right of the division expression is this. So this is being divisible by this expression, and whole of this is again a resultant. This whole of this is again a evaluated result, is again a computed result, and this computed result is assigned to X. This computed result is assigned to X because here again the assignment is acting something like a root node, which is a operator. The left of this root is X and the right of this is something a answer or something a result of this division, something a result of this division. So this is how, again another example of the parse tree. For this again parse tree, it does in the same, it does in the same way. It does in the same way, like it has to load, like it has to multiply. First it has to load B with some register, this B with some register, then it has to use the mult sign, then it has to move this resultant to some temporary variable, then again add to that temporary variable this A, add to that temporary variable to that A, and store this time being the resultant in a temporary variable, and again multiply this B and C, and again that result should be holded or should be stored in some particular temporary variable, and again subtract with A, and later whatever, suppose if it is in T1, this computed value is in T1, T1 is divisible by something like T2. So again this answer is again loaded in some register and again go back and move it to some memory location, that is X. So in this way the code will be generated. In this way the code will be generated. And I am from yesterday I have just shown different example only for assignment. Yesterday's class also I have shown only for assignment. If you see yesterday's example also only I have shown for C. This is how the code is generated for simple. What is the type here? The type here expression is assignment expression. The type here is the assignment expression. What is the assignment expression? Assignment expression timing, it's an expression only, but of course it is an assignment expression because after all it has to assign to some memory location. The result should be holded in some memory location, should be stored in some memory location, not hold it, should get hold of some memory location. So since from yesterday's class, I have just shown you two different examples, and I have just covered the postfix, and I have just covered the three address code. So these all are the method which are used for the code generation, and all of these methods are nothing but they themselves are different variety of expressions. So how they can be solved, so they are themselves a techniques, so they have to follow the parse tree and they have to generate the code accordingly. So here that was one part, and here the basic building I have used only the assignment. But what about the basic building? If I have the for loop, if I have the do while loop, if I have the while loop, if I have the if else, and if I have some other expression, something like infix, infix to postfix we have done. Then if I have in a reverse way, postfix to infix. So if I have such basic building blocks in in languages while performing the code, performing in the sense while executing some our required project or required code. So based on that, programmer will make use of so many basic blocks, several basic blocks. So that's the reason how the compiler has to generate the code. That is very important. So we shall see some another example also. Code generation for this was the first which I have shown for the statements, same as of that. And how would be the code generation for, see here, indexed one, how the code will be generated for the index. I have a statement A is indexed statement. How it is an index statement? I have here an something like an array statement. So here also an array, because usually index statements are array statements, we call them as the array statement. So both the type I am showing here, A is equal to B of I. There is a variable called B, and B is a array variable, and ith is assigned to some memory variable, that is A. And here A of ith is assigned to some content, that is B, value to B. So how the move statement, how the code will be generated here? For this, first we have to move of I. So this is how it will be used for indexed statement. Now it is called as an indexed statement. Here in this, initially we have taken the high level language, here high level statement, that is the array statement, and here it becomes as the indexed statement. Here it becomes as the, yes, are you observing the screen, Onkar? Second example I am taking, code generation for index statement. Code generation for index statement. Next I will be showing the code generation for even the pointer also. So this is second example, code generation for index statement. Usually index statements are the array statements. So how the compiler will generate the assembly code for array statement. How is the array statement? Either A of I is assigned to some value variable, either two-way variable, some ith index is assigned. So both the cases we are seeing here. So both the cases here, A is assigned to, so here I need to use move to some register, and the content of this ith is an ith. Again, ith is also called as a register, ith register. It is moved to some other register. In a reverse way. Again, for this, in a reverse way, move the value, to some ith indexed, to some ith array, and what is the name of the array? A is the name of the array. But here the cost is 3. Why? Because this is a usual notation. Here the cost is less, here the cost, reverse way, the cost is 3. Means the size increases, the size of the memory during the runtime, it increases. Yes, understanding? 1, 2,
Yes, ma'am.
understood?
Yes, ma'am.
3, 4.
Ma'am, roll number 2.
Present, ma'am. 3.
Okay.
4
हाँ
present, ma'am.
हाँ हाँ. 5,
Present, ma'am.
6, 7, 8, 9, 10, 11,
Present, ma'am.
12,
Present, ma'am.
13, 14, 15.
15 present, ma'am.
Okay. 16,
Present, ma'am.
17, 18,
18 present, ma'am.
19. Okay. 19,
Present, ma'am.
20,
Present.
21,
20 present, ma'am.
22, 23, 24,
Present.
25,
Present, ma'am.
26, 27,
27 present, ma'am.
28, 29, 30.
28 present, ma'am.
Okay. 29, 30,
Yes, ma'am. 29
okay.
present.
31, 32,
26 present, ma'am. 32 present, ma'am.
33,
Ma'am, 32 present.
33, 34, 35,
34 present. 34 present.
36, 37,
36 present, ma'am.
38,
Present, ma'am.
39,
Present, ma'am.
40, 41, 42, 43,
Yes, ma'am.
44,
Yes, ma'am.
45, 46,
Yes, ma'am.
47,
Yes, ma'am. 46
48,
present, ma'am.
49, 50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54, 55,
Present, ma'am.
56, 57, 58.
57 present, ma'am. Present.
Okay, okay. 58, 59,
Present.
60, 61,
Present, ma'am.
62, 63, 64, 65,
Present.
66,
Present.
67, 68,
Present.
Present.
68,
Present.
69,
Present.
70, 70.
Present. Ma'am,
Wait, wait,
22 is present. 26 present, ma'am.
wait, I will repeat, wait. Okay, 22 present, 26 present. 6, 7, 10, 13, 17, 21, 29, 30, 31, 33, 35, 41, 42, 51, 52, 58, 60, 62, 63, 64, and 67.
Madam.
Ma'am, roll number 6 is present.
Huh.
Ma'am, roll number 29 is present.
Huh.
Ma'am,
61 is
67
present.
present.
7 is present, ma'am. Roll number 41.
Huh. Hmm.
Ma'am, 42 is present.
67.
Yeah, noted. 67 noted.
51. 7, madam. Ma'am,
Hmm. Which one?
47. 51. Roll number 41 present.
51 noted. 51 is present, noted.
Ma'am, 40
58,
also
ma'am.
present.
14.
Why for 58 is late?
I had given, ma'am.
Okay, okay, noted.
7, ma'am.
Who said recently? What's your number? Ahilya? 7. Why you came now? You are not
Ma'am,
present for the class.
ma'am, I'm present, but due to network issue, I'm unable to give
Okay, okay.
attendance.
Okay, the absentees list 10, 13, 17, 23, 29, 30, 31, 33, 35, 52, 60, 62, 63, 64.
Ma'am, 29 is present.
29 is present.
Yeah.
Anybody? Okay, thank you. Next class, I'll show the pointer. For a pointer, how the code is generated. We have seen now index, how the code is generated. For index. Index in the sense for array, how the code is generated. Today's class, something new, quadruple, triple, and how the code is generated for array. Array means index. Indexing type of the assembly code is generated, because compiler will generate assembly code, na, that code only we are discussing. So for every basic building block, how the code is generated. Thank you all.